In the previous video, we went through and looked at static routing. And as you can tell, there was a couple of little hang-ups that we went through to try to get everything working. And eventually we did. We finally was able to get internet working on our virtual machines that are attached to the logical switches that are connected to the DLRs. The DLR has an uplink to the ESG. All is well. Now, we're going to switch gears and talk about dynamic routing. Now, for any of you that have a Cisco background or Juniper background where you focused mainly on core routing and switching, things like that, you're in a good spot, right? Because you're more than likely already going to be familiar with the basic operations of OSPF, and it's going to make your life that much easier. Same thing with BGP. If you have like a CCNA level of understanding, you're in a good spot. If you have a situation where you've never really been a network guy or gal, you've been more VMware, you've done a lot more server or cloud or Microsoft, maybe Linux, more of a systems admin, systems engineer type of role, then you're probably going to struggle a little bit with this. I'm going to do my best to try to break it down for you. OSPF, when we click on the NSX edges, is one of several different types of dynamic routing protocols. And before I get into how to configure it, let's talk a little bit about what we're going to be doing, because then it'll make it easier to break things down as we're progressing forward. So essentially what we're going to do is we have our DLR that connects to our Edge Services Gateway, and then our ESG connects upstream to a CSR 1KV that connects up to our core switch. Okay, attached to the DLR we have a couple of logical switches. This is also a logical switch, but we're just going to, we'll say LS1 and we'll do LS2. Okay, this is the topology as it sits right now. It's important to really be able to understand the flow, right? If you don't understand how the logic is built in the overlay, then that's where you need to pause, go back to one of the earlier videos, or do some more research to figure that out. So basically what we've done so far is we have static routing here, static routing here, static routing here, and static routing here. That just isn't feasible long term, right? I mean, static routes are not cool. So I'm going to back all that out. And what we're going to do is we're going to roll out OSPF. Now the way that this works is OSPF uses the concept of areas. And the reason I bring this up is because the way that NSX deploys OSPF is in an Area 0 and in an Area 51 design. Way to go, VMware, for choosing Area 51. No pun intended, right? What we're going to basically do on the ESG and the DLR and the CSR 1000V, CSR 1000V is already running OSPF between the CSR 1000V and the core. So we already have OSPF neighbors here. There's a bunch of OSPF routes being learned on the CSR. Our job now is to enable OSPF on this link right here, this link right here, and these links right here, so that we can advertise all of this. So how do we do that? Well, the answer is the ESG. So we're going to start at the ESG and work our way backwards. Normally I would do it on the DLR, but I'm going to do it on the ESG just to show you the flow of how this works. So from here to here, this will be in Area 0, or the backbone area. From here to here, we will be in Area 51. And what we're going to do is this link right here will be in Area 51, this link will be in Area 51, and so will this one. The DLR is going to take these logical switches and he is actually going to redistribute them into OSPF. There's going to be a redistribution statement that's done. It's automatically there. We're just going to validate that it's actually working. And the ESG is going to connect. I have a couple of links. We're going to have the distributed port group configured to run OSPF Area 0, and the downlink, the transit link between the ESG and the DLR is going to be in area 51, and that's going to allow us to get the communication end to end. Do I have to do area 51? You don't have to do area 51. There are ways of creating it, creating other areas on the DLR and the ESG. It just, for this particular scenario, I'm going to go with the defaults and just roll with them. And we're going to eventually end up getting OSPF learned routes down to the DLR. Now, this will allow the logical switches and the devices attached to those logical switches to connect to the internet via dynamic routing. Now, what I'm going to go through and do is I'm going to actually remove all of the static routes first. That's the first thing I need to do, because static routing will always be more preferred than any dynamic routing. So that's the first thing I have to do is remove all the static routes. So I'm going to go ahead and pull up the CSR1000V, which is this guy, or this is my core switch. I'm going to go ahead and I'm going to restart the session. Give that a couple seconds. We're going to accept the security key. I'm going to log in. I'm going to do a show run pipe include IP route. Get rid of all the static routing. Go up here and type in no and pull these guys out. Pull that out and pull this out. Alright, now that I got that done, the next thing is to jump on to the CSR. Show run pipe include IP route. I'm going to go ahead and say no default route here. No default route here. Like so. Now if I was to do show IP route here, we can see that we do have a default route in the routing table on our core switch. And if I say no IP route, no default route here, oops, pull this out and do show IP route, you're going to see that we don't have a default route being propagated down to us. We can fix that on the switch here, because if I was to do show IP OSPF database, there is no default route being originated from the core switch down to the NSX or the CSR1000V, which is this guy right here. I will fix that when we get there, and I'll show you guys how to do that. It's actually pretty easy to do. So that's that. I'm going to go to the Edge Services Gateway. I'm going to go to the Routing tab, and I'm actually going to get rid of this default route. So I'm going to go to here and click on Delete. Delete that. That'll take a couple seconds for it to get yanked out. And I'm going to go to Static Routes, and I'm going to get rid of both static routes. Let's go ahead and delete. Yes. Delete. Yes. Then we'll go and publish those changes. We'll give that a second or so to do its thing. Once that's been done, we'll be able to go over to the DLR and get him configured as well. Edge 3, coming over here to routing, static route, I'm going to go ahead and delete, even though technically speaking it wasn't even working. And static routes, we had none. Okay, so all the routing has been removed at this point. So I'm going to actually go over here to my vCenter side of the house, and I'm going to click on the DLR. I'm going to say launch web console. And the same thing with the ESG. Launch web console. Move my tab to the right here. Click on OK. And on the DLR, let's reverse those. Click in here and go. We do a show IP route. Guess what? No default route there anymore. Only connected is showing up. Click inside of here. Show IP route. Guess what? No more default route. Now I'm going to go back to here, and I'm going to start on the ESG, so Edge 2. I'm going to go over here to routing. First thing I have to do when it comes to dynamic routing is click on Edit, and I have to give this guy a router ID. The router ID is going to be an identifier that is going to be used to differentiate each node or each router that's providing routing from each other. And the reason why we want that to be is if router 1 has a router ID of 1.1.1.1 and router 2 has a router ID of 1.1.1.2, if router 1 advertises a route to router 2 will see that route being advertised to it from router 1, look in the OSPF update and go, oh, okay, well that's from 1.1.1.1. What's cool about that is if router 2 re-originates that route again and sends it back up to router 1, it's going to have router 1's original router ID in the update. Router 1 receives that in and goes, oh, well, hey, I already know about that route. You don't have to advertise it to me. So it's a loop prevention mechanism. It goes out and it sees if a router receives an update from another router, but that update has the router that's receiving the update, if it sees its own router ID in the update, it knows that it originated the route up by originally, and so there's no reason for it to have that route be received. So I'm going to put 1.1.1.1. Something very, very obvious, because I don't want to be using the interfaces to do that. And I'm going to go ahead and publish, and I'm also going to come down here to edit just to make sure that everything's working. Cool, cancel on that. Next thing is to go to OSPF. We're going to go to edit here, and we're going to start OSPF. And back on the CSR, if we look right here, remember we're not receiving any routes from the upstream router, which we will fix here in just a moment. So we have the ability of doing a default originate, which means we're going to propagate a default route. Right now we don't have a default route, but once we do, I'm going to go ahead and propagate it down to my DLR. I'm going to click on save, and I'm going to go ahead and publish. I'm going to go here, and you'll notice that I have area 0 and I have area 51 with a not so stubby area. Not so stubby area, or NSSA, simply means that you are going to allow redistribution into a stub area. But the redistribution route type will be type 7. A type 7 route is a route that is redistributed from the outside of that area into that area, but a stub area can't have a type 4 or type 5 LSA. Type 4 and type 5 LSAs indicate you have a route to outside of the network. It's an external route, meaning that it's outside of the OSPF domain, and that route, type 4, means you're pointing to a area border router to reach the default route that exists in another area. Another area has connectivity to that default route, or a type 5 LSA means that you're in the same area as the default route. So I'm going to go ahead and not mess with that, but interface mapping. If I go in here, I click on add, the first area interface, I have two options, right? I have transit and I have uplink. In uplink, I'm going to associate area 0 because that's going to be my uplink to the CSR 1000V. And I'm going to use the defaults. It's a hello interval of 10 seconds, the dead interval 40, which the dead interval will always be 4 times the hello. So these are the defaults. These can be modified down. The priority is 128. Priority is specific to the designated router, backup designated router election process. We're not really going to get into that right now, but if we wanted to make one router, the ESG, more preferred than the DLR when it comes to the designated router election process, then we could adjust the priority appropriately. The cost is a value of 1 because we're dealing with gigabit connectivity. So obviously if you had, say, a DLR and 2 upstream edge services gateways like this, if you had a situation where you had, say, ESG 1 and you had ESG 2 and you had a DLR 1 and you had connectivity to both and they're both running OSPF, you could say not on this side of the ESG, you'd have to do it on the DLR side. You could say a cost of 1 here and a cost of 2 here, which means traffic would actually be preferred to go this path. So it would allow you to do some traffic engineering in your environment. And if ESG1 went down, ESG2 would automatically kick in. Now, you don't have to do that. If you wanted to leave them both the same cost, DLR1 would forward traffic to both ESG1 and ESG2, assuming that you've turned on equal cost multipath. So that being said, let's go continue our configuration. I'm going to click on add, and then I'm going to add another uplink or another connection, and this one's going to be transit, and it's going to be area 51. I'm going to go ahead and click on add. Now, one thing I want to point out here is the ignore interface MTU settings. By default, OSPF needs to make sure that both interfaces that you're setting up for OSPF have the same MTU value. And that shouldn't be a problem here, but if we notice that OSPF adjacencies are not forming, I will have to disable it'll be the ignore interface MTU command so that we can get the connection up and running. So if we run into a problem, typically this is going to be more of a CSR1000V to the ESG on the uplink side would potentially be the problem, but we'll cover that when we get there. So they're both squared away. So we have uplink is area 0, transit is going to be 51. I'm going to go ahead and publish that config. And that's going to go ahead and push that config down on the ESG. If we come up here, we do a show IP route. Obviously nothing's happening. If I was to do a show IP OSPF neighbor, nothing's there. If I was to put an interface and hit the interface, I could see that I'm VNIC1 and VNIC2, 10.10.10.02 and 172.29.11.1 are both enabled for OSPF. It's now complete. Now I get to go configure the DLR. The DLR, I'm going to go down to here, click on Edge 3. I'm going to go down to routing. Same thing. I'm going to have to go to here, edit, and configure the custom router ID. This one here is going to be 1.1.1.2. I like to give it something very, very unusual so that it jumps out at me, so I know which device I'm working with. Now OSPF, I'm going to come in here and edit. I'm going to go ahead and say interface. I'm going to associate this uplink. This is going to be the transit link and the protocol address. I'm going to go ahead and enable this. What I'm basically going to do now is the protocol address is going to be an address that is used for routing updates and things like that. So I'm going to put in here 172.29.11.254. Something inside the subnet. I'm going to click on save. I'm going to go ahead and publish that. It's got to be in the same subnet though. That's the key thing. And it has to be an open IP address. So you can point to this IP address and this will hit the DLR. I'm going to go to area definitions. We can see that area 51 is the only area that we've got. And if I click on area add mapping, I'm going to, in the transit link, we're going to go with all these defaults. We're basically enabling OSPF on the transit link, which is the uplink on the DLR, but it's an internal interface on the ESG. I'm going to go ahead and click on add and then publish. All right. That's going to go ahead and push that data out. And lastly, give that a couple seconds to do its thing. Route redistribution. We need to make sure that for OSPF, route redistribution is enabled. And for OSPF, in the route redistribution table, we need to make sure that OSPF is advertising connected interfaces. On the DLR, if I look here, I have 172.29.1, 172.29.2, right? If I hit the up arrow, right, now we're starting to see routes coming in. We see the OSPF route coming in from 172.29.11.1, which means that the ESG is actually propagating a route down to us. And this OSPF inter-area route, this OIA route, which says OSPF and then next to it says IA, that stands for inter-area. So what's happening is the upstream link on the ESG that connects to the CSR1000V is in area 0. The connection from the ESG to the DLR is in area 51. Two different areas. That means that the ESG is acting as an area border router or an ABR. Because the ABR is going to take the routes that are coming from area 0 and is going to push them down to area 51 to connect to the DLR, he is going to propagate a type 3 LSA. If we were to do a show IP OSPF database, you're going to see the type 3 LSA is right here. Let me go find my mouse. This right here is the type 3 LSA right here. The summary network link states. So up here at the top we have type 1 LSAs. These guys right here are type 1 LSAs. We have our type 2 LSA, which is our designated router election, which is why that priority comes into play. We have our type 3 LSA, and the advertising router is 1.1.1.1, and we can see that the DLR is learning those routes. If we go to the ESG and we do a show IP OSPF neighbor, I have a neighbor to 1.1.1.2. The address is 172.29.11.254, which is going to be my protocol address. So the control VM that was used to deploy the DLR with is actually hosting the peering. And then he is going to receive the updates, and then because he is the control plane piece of that, he's going to push those updates down to the DLRs that are configured on the devices. So I'm going to go ahead and do a show IP route, and we should see some stuff coming in. We see N2 at OSPF, not so stubby area, external type 2 routes, 172.29.1.1 or 29.1 and 29.2 via 11.2. Next thing to go up here and do is we notice we don't have an adjacency with the CSR. So let's go and actually set that up. Let's go up here and we're going to do show IP interface brief. I'm going to go to interface gig 2.100 and type in IP OSPF 1 area 0. So I should get an OSPF adjacency to form on that link here momentarily. Show run section OSPF. So if I do a show IP OSPF neighbor, I am still waiting for the connection to come online. It's an X star, which means they're trying to extend the information back and forth. Now you see that this problem, right? We notice that the link isn't coming online, right? We're in X star. This means that there's an MTU problem. Okay, so what I have two choices. Either I can go show run interface gig 2.100, and I can go to here and type in interface gig 2.100 and type in IP OSPF MTU ignore, right? And that should form my adjacency. And then I can go see if that's any further along. Let's go back to the NSX edges, specifically to the ESG. And on the routing bit, come down to OSPF. And for the uplink, we're going to edit this. And we're going to uncheck the ignore interface MTU setting. Click on save. Publish. Now it should technically work just fine without it. There's my adjacency. So my adjacency came online now. Both sides have to agree on it. So if we were to do a show interface gig 2, technically speaking, he is running at, where's the MTU? Did I not show run interface gig 2? I've got an MTU of 9,000. So it should automatically do it. But if I do a show IP route OSPF, when we come down here, we're going to learn these 172.29 routes. They're external type 2 routes. And if I come down here to the DLR and I hit the up arrow, I'm going to learn a whole bunch of additional routes, right? If I do a show IP route, I'm going to learn a bunch of OSPF routes here in the network. So what's cool about this is I've actually got a lot of reachability set out to a lot of different places. So now if I go back to here and I click on LVM1 and I click on launch the console, I should have internet access. Go ahead and log into this guy real quick. That might take a moment or so. If I do a ping to google.com, I should, well, that's weird. Not sure why it doesn't have, oh, this device is, might have to reboot this box. That's just weird. Let me grab a different device. One that isn't giving me as many headaches. I will have to change the host name on this box, because LVM1 will be a little, because I am deploying from a template. Let's go ahead and open terminal. Give that a couple seconds. And then we're going to go ahead and do a ping to google.com. Well, let's do some internal pings first. Let's ping quad 8. Can I ping that? Destination host unreachable. Okay. Let's see what that means. So let's go back over here to our devices. And let's go ahead and restart session. See why this isn't connecting. So if we do a show IP OSPF neighbor, I have a full adjacency via OSPF to that box, which is what I want. If I look at the CSR, show IP OSPF neighbor. If I do a show IP route, oh, that's because the gateway of last resort's not set. So I'm glad you guys actually got to see that. So what I'll do is up here, do show run pipe section OSPF. I will fix that real quick. It's not going to take us long to do. So underneath OSPF router OSPF 1, I'm going to type in the command default dash information originate and hit the enter key. Now what's going to happen over here, if I was to do on the CSR show IP OSPF database, we are now going to receive a default route in from that guy. And if I show IP route again, we're going to have a default route in the routing table after it's finished doing its figure it out stuff. I do see it in the database, so I'm not sure why it's not injecting. Might take it a couple seconds for it to trigger. But if that doesn't work, I can always, because this guy should have a default route in the routing table. Yeah, he has a default route. Not sure why this is taking so long. Because the gateway of last resort is not set currently. Let me go ahead and just throw a default route in to 21. Let's see. Actually, that's the whole thing. I need to. What was my default route before? Let me do a quick do show startup dash config. What was my static route? Did I not configure a default route? I guess I never did. Okay, not that big of a deal. So let's minimize this. Let's do a do show IP route. Yeah, it's not populating. So do show IP OSPF neighbor. I'm going to connect to 21. I'm going to just point to an IP route, a default to 10.255.1.21, which will be the switch's IP. And do show IP route now. The default route is there. And if I come down here to this guy and I hit the up arrow, now the reachability is in play because the upstream box wasn't propagating it. So if I was to ping Google, that should respond as well now. So the problem was that I wasn't actually able to reach it because the networking configuration, the routing from the core switch to my CSR 1000V was being a little bit weird. So we're good to go now in terms of the operations. So we're in good shape now. And so we have reachability via OSPF to the upstream box and all that good stuff. So that's the important piece. We have reachability where we need it to be. Let me go test it from here now. That's what I thought. Cool. All right. That is it, ladies and gentlemen. Thanks so much for stopping by and hanging out with me, and I'll catch all of you guys in the next video.